conditional statements and definitions. Okay, and you will want your highlighters out. So by conditional statements, maybe you notice that by conditional, the main root of that word is what? That's the prefix, right? So conditional is the main word. Do we remember what a conditional statement is?
It's if then.
Yeah, it's a if-then statement, right? If P, then Q. And then, yep, the by is the prefix, and by means two. So basically what this is, it's two conditional statements put together. And there is a special way that we put them together. So a biconditional statement is a statement that can be written in the form P if and only if Q. Okay, so a biconditional statement is a statement that can be written in the form P if and only if Q. This means, this should say then, if P, then Q, and if Q, then P. Okay, so just to reiterate, if you have a statement that's a biconditional, it means both P goes to Q and Q goes to P. Okay, so it's forwards and backwards. Okay, so P to Q, Q to P, that means it's the conditional and its converse put together. Okay, a biconditional statement is a combination of the conditional and its converse. And then another way that you can write this, so this is shorthand. Instead of writing out if and only if, sometimes you'll see the abbreviation IFF. It is not if misspelled. It means if and only if. Okay, so that's a special notation. All right, so for our first example, let's figure out what we have to do. So it says to write the conditional statement and converse within each biconditional. So we have to write, what do we have to write? The conditional statement and the converse. Okay, and the reason why I'm stressing the directions is here on my example sheet, I have this written for you. When you're doing your homework, you're going to have to make sure you interpret the directions and know exactly what to write out. So you should have 2 sentences for this. So this is actually another notation for it. So P, if and only if Q. You might also see, we'll write this above, P, and then it'll be the double-sided arrow, which is what we have here. Okay, so a solution is neutral, that is your P statement. Its pH is 7, that is your Q statement. So if we're writing a conditional, we have to write it in the form if P, then Q. Okay, I want you to think about what you're going to write for the conditional. If you're feeling confident, you can write it down.
For like a normal conditional or for
Yes. Nope. Just the condition. Okay, Anakin, tell me what you're thinking about for that one. How would we write that?
If a solution is neutral, then its pH is 7.
Great. Okay, if a solution is neutral, then its pH is 7. Okay, are a lot of you in physical science right now?
no, we're in biology.
In biology? Okay. When you get to chemistry, you'll learn more about different solutions and what their pH is. It's either acidic or basic. Did you guys do any of that in middle school? Okay. All right. So the pH is 7. That means that it's a neutral statement. Okay. And then as the numbers rise and fall, it's more acidic and more basic. So for the converse you're going to switch your P and your Q. So Griffin, what's that going to be?
If a solution has a pH of 7, then it is neutral.
Good. If a solution has a pH of 7, then it is a neutral. Okay, and you can use its here. I just want to point out to you, if you use its here, it's IT apostrophe S because it is. This should not have an apostrophe because it's talking about possession, right? Its pH, the pH is belonging to the solution. Okay, so that was our Q to P. All right, now I want you guys to try to do part B, and then I'll have you check that in with your OWL partner. Okay, so I'll give you about a minute to do that. So you're writing the conditional and you're writing the converse. Okay, and then remember when you're done, I want you to check in with your OWL partner. Okay, so hopefully when you guys did this, you started off labeling what your P and your Q are, right? So for P, an angle is obtuse. For Q, its measure is greater than 90 and less than 180. Okay, Rachel, what did you get for your conditional? Mm-hmm. Okay, so instead of using the if and only if, we want to change it so that it's the if P then Q. Okay, so what we need to do is we need to start it with if, which you did, right? Yeah. Yep. So if an angle is obtuse, no, and then you say then its measure is greater than 90 and less than 180. Okay, so you'll only have the if and only if it's a biconditional. The conditional is going to be in the form if then. Okay, and then Ashton, tell me what you got for the converse.
If an angle's measure is greater than 90 degrees and less than 180, then the angle is obtuse.
Okay, good. All right, so I'm gonna let you guys look at mine. Okay, so your conditional, your P to Q. If an angle is obtuse, then its measure is greater than 90 and less than 180. So you have P to Q. This one will be Q to P. Okay, and they both have to have if then. Okay, so what you're doing is you're taking the biconditional, which is the if and only if, you're separating it into those two statements. Okay. What question do you guys have for me on that? All right, let's go to the next one then. So for our next example, it says for each conditional, write the converse. And it should say as a biconditional statement. So let's change that. Write the converse. Oh, no. For each conditional, you're going to write the converse and a biconditional statement. So you're going to write both. Let's underline our directions. Okay, so for each one, we have to write the converse and a biconditional statement. So when we're writing the converse, bless you, Ireland, what's the form of the converse?
If not Q, then not P.
That you're thinking of something else. So remember, you have the conditional, and then the converse is. You switch it.
If not P.
No, you're negating it.
Oh, sorry. Okay. Q, if Q, then P.
Right. Yes. Okay. So if Q, then P. So your converse will be if Q, then P. The biconditional is what we learned today. The biconditional is P if and only if Q. And I'm just going to write the if and only if above since we're still kind of new. I want you to know we have to put that in. And then Q to P is still an if-then type statement. All right, so for part A, it says if two angles have the same measure, then they are congruent. So let's pick out what our hypothesis and conclusion are. Okay, Max, what's my hypothesis? Good, okay, so two angles have the same measure. That is my hypothesis, so I will label that as P. All right, and then Ziggy, what's my conclusion? They are congruent. Good. Okay, so then for the converse, I'm going to say if Q, then P. Okay, if Q, then P. Okay, and Colin, will you tell me what that will be? So for your converse, right?
Alright, for the converse,
Mhm.
x equals 9, then 5x minus 8.
Wrong one. Okay, I'll give you guys a second to write this down, and then I'll have you guys
If
help
two
me.
angles are congruent, then they have the same measure.
Okay, so you guys try to write that down. Think about what you're gonna write for the biconditional. Okay, so it is if two angles are congruent. Sorry, I'm gonna write this out. If two angles are congruent, then they have the same measure. All right, and then we're going to do the biconditional. Okay, so for the biconditional, you do not start with an if or then. You're going to start directly with P. So my P statement is two angles have the same measure. And make sure you guys are starting your sentences with a capital letter, because I was grading your quizzes last night and I was shocked and appalled at all these lowercase i's that we have going on. Right, so two angles have the same measure if and only if they are congruent. Okay, so two angles have the same measure if and only if they are congruent. Okay, so I'm taking exactly what P said, if and only if, exactly what Q said. Yes.
So, like, when you're writing those out, if you do, like, the IFF, will you get marked down for that, or do you,
No.
like,
Nope,
want,
you-
like, if and only if?
You could do IFF. Yep, that'd be fine. Yep. Okay, so I want you guys to go ahead and do B.
So you don't put the if and then you have it.
Wait, this. IFF, right?
Okay, and then Claire, tell me what you got for the converse.
Me?
Yep.
If x equals 9, then 5x minus 8 equals 37.
Good. If x equals 9, then 5x minus 8 equals 37. Okay, and then again, if you guys want to label, here's your P, here is your Q. Okay, and then Ryan, what did you get for your biconditional?
For my biconditional, I got 5x minus 8 equals 37 if and only if.
Good. If and only if x equals 9. Perfect. All right, let's turn it over. So the next thing we're going to talk about are truth values. So in order for the biconditional statement to be true, both the conditional and the converse must be true. Okay, so both P to Q and Q to P have to be true for the if and only if statement to be true. Okay, so that's really important because sometimes P to Q is true, but Q to P is not, or vice versa. Okay, so it has to be true forwards and backwards. Okay, so for the next one, it says determine if each biconditional is true. If it is false, you have to give a counter example. So the first thing you're going to do is say whether it's true or false. Okay, if it's true, you're good. If it's false, then you have to give a counter example. Remember with counter examples, the hypothesis has to be true, and then you show that the conclusion is false. Okay, so for our next example, I want you to go ahead and write the conditional and the converse from the biconditional. I'll give you some time to do that.
So anytime it says condition,
so after you write out the conditional and the converse, determine if they are true or false, okay, each one. Okay, so let's go over the first one. So your conditional is if an angle is a right angle, then its measure is 90. If an angle is a right angle, then its measure is 90. Is that true or false?
True.
True, right? If it's a right angle, yep, it's 90 degrees. The converse, if an angle has a measure of 90 degrees, then it's a right angle. Is that true?
Yeah.
Yes. Okay, so when I write these down, what I do is I'll write it next to each statement, but you have to determine if the biconditional is true. So because the conditional and converse are both true, your final answer will be true. But I need you to understand that's because both of these are true. Okay, and it looked like a lot of you guys already got a chance to look at part B, so we're going to look at this part first. Okay, so here's your conditional statement, or your biconditional statement, and then your conditional is if y equals -5, then y squared equals 25. Okay, that is true, because if y equals -5, when you square -5, are you always going to get 25? Yes,
Yeah.
every single time, right? -5 times -5 is always going to be positive 25. All right, now the converse says if y squared was equal to 25, then y equals -5. So, if y squared equals 25, what you need to ask yourself is the only possible solution -5? No, what's the other one? 5. We actually talked about this yesterday. So remember, if it's false, you have to give a counter example. So the converse is false. Your counter example would be y equals 5, because if you plug in 5, isn't 5 squared also 25? Yes. Right? And you are going to run into these situations when you have the square. So y squared, x squared. Okay, so if the conditional is true and the converse is false, the biconditional is false. Okay, so in order to be true, they both have to be true. If it's false, just one has to be false. Okay, so true, both have to be true. False, just one has to be false. Okay? All right. That's you. So let's look at the last part. So a good, precise definition can be used forward and backward. Okay, a good, precise definition can be used forward and backward, which probably means we're going to start taking definitions and write them as what? The biconditional, right? The biconditional, it has to be true. Forwards and backwards, the P to Q and then the Q to P. Okay, so that's what we're going to do with our next example. So in case you didn't get this, it was forward and backward. So our example says, if a figure is a quadrilateral, then it is a four-sided polygon. The next statement, if a figure is a four-sided polygon, then it is a quadrilateral. Okay, so what we can do is we can rewrite that as a biconditional statement. Okay, so as an example, this would be a figure is a quadrilateral if and only if it is a four-sided polygon. Okay, also if I write out a word for you or you see it spelled correctly here, I want you to spell it correctly when you write it too, okay? Yeah, and some other words from our quiz. Okay, so to be sure a definition is precise, it helps to write it as a biconditional. So that is what we are going to do in our next example. So we're going to take the definition and we are going to write each definition as a biconditional. Oh, and the pentagon should say a pentagon is a five-sided polygon. Like when you started it, did you say a shape? Yeah, that's fine. Okay, so remember with the birds, we had the birds and the blue jays, and in general, all birds are animals, right? So we added that in. So all polygons, you guys could use shape, or another common word you'll see is figure. So a figure is a pentagon if and only if, and you can just do the IFF, it is a five-sided polygon. Okay, and then the next one, it says a right angle measures 90 degrees. So go ahead and see if you can write that with your if and only if. Okay, so a right angle measures 90 degrees. Okay, and then Matt, tell me what you got for this one.
An angle is only a right angle if and only if it measures 90 degrees.
Okay, good. Okay, so an angle is a right angle if and only if it measures 90 degrees. Okay, and you notice here I switch things up. I put the double-sided arrow in there. Again, you can do the if and only if. I just want to expose you to different ways that you can write that down. All right, so I'm going to have you write down your homework as well. And you can keep out your notebook because I'm going to have you staple that in. And then I'm going to have you put everything else away in your bag. and then I'll have you put your phones in your bag, and then, yep, we'll look at our chapter 1 test. Okay, so the first thing I'm gonna do is I'm just gonna show you how to put this in your notebook, and then I'll let you guys pack up your stuff and you can move it. Stay with me for another minute. Okay, so when you fold it, you just wanna be able to obviously read what is also happening here. So mine, I'm just gonna fold after part B. Okay, after part B, so this is on the bottom. Okay, and then it folds right here. So when you guys are stapling this into your notebook, it's the same thing as yesterday. You're gonna put this close to the edge, and then you're just gonna do one staple in the middle there. When you just do one staple, it's easy to open it up, okay, so that you can read it.
What was the last, okay, what's the middle number? 10 through 22.
Oh, sorry. I'll put that up.
I just messed up all my numbers, so I can't.
Oh, yeah, no